Hi everybody, I wanted to show you these little lights that I've modified. You can get these little lights at most trustworthy hardware stores or other places. They run about $3 to $4 a piece. They got 24 LEDs in the front and or on top and 3 in the front. I've got this one basically dismantled. I just got it back together for illustration. But if you push this button, this light will come on. You push it again, it'll go off. Push it again, this one will come on. Okay, what I've done is I've rewired the circuit so that I've got 24 LEDs here and one extra one to give me a total of 25. But when I click it once, it comes on, off, on, so you get the idea there. Okay, I'm going to kill the power here, and then I'm going to show you some of these. I've had both. Some of them have got 3 screws in the back and some of them don't. This one here does not. You just pop the back case, it exposes the battery, and one of the things that you can do is reach a Phillips screwdriver down through the back and you'll get a little tiny button magnet out of the deal. You can salvage the 3 AAA batteries, and then there's screws, 4 screws holding the face to this. I've already removed the screws, so it's just a matter of popping the case open now. Remove the case, and then it's got a shield, and that shield will come, or not shield, but reflector. And then there's either 1 or 2 screws right here. Remove those screws, and then this will come out. Now you have a little battery case for whatever. Now, as this little circuit board is, it has these 3 LEDs on the back. That's for the front of it. I desoldered these and completely removed them from the circuit board. The next thing I did is I desoldered this resistor and removed it, and I replaced it with tinned copper, and you can see it's about the same size as the wire on that resistor. It'll actually fit through these little holes. There's little holes in the circuit board. So replace that one, get rid of the resistor and replace it with tinned wire, and then come around by the button and remove that resistor and do the same thing. Replace it and solder it to the connections on the back with tinned wire. Okay, the next thing I do is I'm going to grab this one because it's going to make it a little easier to see, is between this solder joint and this one, I soldered a tinned wire in there. You have to do this or it's not going to work. And that's pretty simple. And one of the LEDs that I removed from the back, I clipped it and I stuck it in the 2 little holes right there, right in front of the switch. The only thing you'll have to take notice is when you look at these LEDs, this one here is going to be turned 180 degrees as opposed to the rest of these. If you put it in backwards, that's not going to light because they are diodes. The other thing I did is I don't know if I'm going to use these reflectors or not, but I took a router bit and I routed the very front of that so that the reflector would fit back on there. And my plan is that I'm going to put a bunch of these either on a piece of wood or plexiglass or whatever, and I'm going to wire them all together in a parallel circuit so that you can provide power. I'm going to use one of these for the positive and negative lugs. One side of this will go to all the lights, and the other side will, of course, go to whatever you're testing. But that's kind of nice because you can increment the load on your circuit that you're checking with 25 LEDs at a time. In this instance here, I got 200, 4 and 4. But I think I'm going to eventually have 400 LEDs on a board. I'm going to have twice this much. It's a lot better than this stuff. This stuff is messy. You got all the wires, and I just been fighting it and fighting it. Finally, I said I'm going to do this. Anyway, hope you've enjoyed. I'll try to include some snapshots after this movie for better illustration. Thank you.